G'day and welcome to the next video on this linear function series. So we'll be chatting about perpendicular and parallel lines. So a couple of things first of all, what are parallel lines? Well, as you can see in this diagram that I've got down here, our parallel lines are two lines that have the same slope. Often people think about them as things like train tracks, and some people say, oh, well, they'll never meet. The key definition is that they actually have the equal gradient. So the gradient's the same. As you see on this diagram, I've got both the gradients of those lines. Remember, we represent our gradient with the lowercase m as 3/2. And so these are parallel lines. So by definition, just going up to the top there, parallel lines have equal gradients. And so we can easily identify whether two lines are parallel because they have the same gradient, or if we're trying to find a line that is parallel to something else, we just make it have the same gradient. The other types of lines that we're going to look at are what we call perpendicular lines. And as you can see by this pink line that I've got down here, our perpendicular lines are at right angles, they're at 90 degrees. And you can see I've indicated it by this 90-degree little symbol there. So the key thing for perpendicular lines is that in fact their gradients are the opposite signs, but they're also the reciprocal. Now reciprocal is a bit of a funky word for some of you, but a reciprocal, basically we invert our fraction, so we flip it upside down. So you can see here, if I've got the gradients equal to 3/2, the perpendicular line is going to have a gradient of, as I said, we switch the sign, so it'll be negative 2/3. And so quite clearly back on our diagram down the bottom here, if I've got those two lines that have got a gradient of 3/2, the perpendicular, if they're going to have a positive gradient, well, quite clearly it's going to have a negative gradient. And in this circumstance, we invert that 3/2 to become 2/3. You may be wondering, well, what do I do if it's a whole number? So for example, in this circumstance where I've got m1 equals -3, so basically with that, well, we think about if I've got a whole number, it's just the same as 3/1. And so when I invert that, it's just going to become 1/3, once again switching the sign. So let's have a look at some examples and how we can play around with those. So let's say the gradient of a line is 4. Find the gradient of, first of all, a parallel line. Well, what have we just said? We said the gradient is equal to the same. So parallel line is just going to be m equals 4. Exactly the same. With the perpendicular line, we change the sign and we invert it. So for this one, it's going to be negative 1/4. Simple as that. Bit of a harder question now. Find the equation of the line parallel to y equals 4x minus 2 that passes through the point 3,5. All right, so when we consider this, we know that m1, when we just use a little subscript there to show that m1 is this line, it equals 4. Okay, remember in our equation y equals mx plus b, we represent that, so y equals mx plus b, where b is our y-intercept. So our gradient here, we've got m1 is 4. So therefore, because they're parallel, we know that m2 equals 4. And so now we can say, therefore, that y equals 4x plus b. And all we've got to do is find out what that y-intercept is. And so to do that, we're just going to use our point here, and we're going to substitute it into this equation. So I'm told that when x is 3, at that point, y equals 5. So we'll make y 5 equals, well, there's our 4, same as our gradient. So now when x is 3 here, so I'm just substituting that point in, and we're going to be able to solve this to find out what b is. So I'm going to get 5 equals 12 plus b, and moving that across, I get b equals -7. And so therefore we can say that our final equation is just going to be y equals 4x minus 7. Okay, and that's the equation of that line. Next one, find the equation of the line perpendicular to the line 3x minus 4y equals 3 and passes through the point -2, 6. All right, so very similar to the first one that we just had there, except we've got a perpendicular line, and the other thing is my equation is not written in y equals mx plus b form. So first of all, let's rearrange this equation here to get it into y equals mx plus b form to find the gradient. It's probably the easiest way, so I'm going to go 3x minus 4y equals 3. Well, let's just move our, I'm going to move my 3x over, so I'll get minus 4y equals minus 3x plus 3. And the easiest thing for me to do here now is just to divide everything by minus 4. So I can go y equals, well, minus 3 divided by minus 4 becomes positive 3 over 4 x. And this becomes minus 3 over 4. So you can see I've just divided everything by minus 4 there. And so from this, my m1 is going to equal that coefficient of x there, which is 3/4. So because I've got a perpendicular, therefore for perpendicular lines, I know that m2 is going to equal, I switch the sign, so negative, and I invert it, 4 over 3. Last thing I need to do is rewrite it as my equation, so therefore y equals minus 4 over 3 x plus b, and now I'm going to substitute in this point here right into that equation. So when x is minus 2, y is 6. So 6 equals minus 4 over 3 minus 2 plus b. And we're going to expand and simplify. So minus 4 times minus 2 is going to be positive 8 over 3 plus my b. A little bit of manipulation. I'll move that minus 8 over 3 to the other side. And again, b equals, well, 6. 18 minus 8 is going to be 10 over 3. And so therefore my equation is y equals minus 4 on 3 x plus 10 over 3. A little bit messy, but there you have it. That is the equation of the line perpendicular to the line and passing through that point. A last note I will say is that yes, we can easily find the gradient of the perpendicular by taking the negative reciprocal, but the same identity applies. Also note, for perpendicular lines, that m1 times m2 equals negative 1, all right, which leads us to the same thing, that m1 equals negative 1 over m2. So that's how we get that idea of the reciprocals, and we can use that for our perpendicular lines. All right, guys, I hope that makes sense to you. All the best.